We're getting into science class. Yesterday we started how do waves carry energy. We talked about the different types of waves. You learned two of them, the transversal wave and the compressional wave. Remember, transversal, different direction, up and down when it goes left to right. Compressional, same direction, back and forth as it did. Guys, but remember when we talked about the electromagnetic spectrum that there's two types of microwaves here at the end. This television signals are, I'm sorry, I said microwaves, radio waves, as well as just radio waves that go along with it. But that's your electromagnetic spectrum. Today we're going to talk about what happens with this visible light that we see. This that we're going to have to keep straight as we work through this. What light can do as it passes through things. You got your fill in the blanks ready. You have a worksheet, obviously, that goes along the last 2 days that you can also work on as we do this. Let's get started. Choice one of what light can do. It can be absorbed, it can be refracted, and it can be reflected. Okay, so keep that in mind. There are three things that materials can do to light. Absorb it, refract it, and reflect it. We're going to start with absorbing it. Shine a light on a piece of glass and most of the light travels through it. Shine the same light on a piece of metal and no light goes through it. Light can behave in different ways when it strikes matter. Some light may be absorbed, which means taken in by the matter. That would be what happens when I shine it on metal. The metal just absorbs it. When light enters a material, some of the light energy is changed into heat energy. You may have noticed this on a warm summer day. Dark colored materials absorb more sunlight than light colored materials. So I'm going to buy myself a winter jacket to stay warm, guys. I should buy a black winter jacket because that's going to absorb the most sunlight and give me the most heat in the winter. It's a really hot summer day. I should be wearing a white t-shirt because that will absorb less sunlight. It'll keep me slightly cooler. Okay, so it's just the amount that it absorbs. We'll talk at the end on why that is. Wearing a black shirt, for example, makes you warmer than wearing a white shirt. Light may also pass through a material without being absorbed. The amount of light that passes through a material depends on the type of material. Almost all light passes through transparent materials, such as clear glass and water. Okay, guys, so at the beginning of the lesson we talked there's three things light can do. It can absorb, it can refract, it can reflect. Now we're going to talk about the three different types of materials. They are transparent, translucent, and opaque. So try to keep those things straight for us. We pass through transparent, that's like glass or water. Translucent, which is number 7 already on your notes, only allows some of the light that strikes them to pass through it. Wax paper is your example of translucent material. So I can kind of see through it, but not completely, right? So some light through, not all. Opaque, number 8 material, doesn't allow any light that strikes it to pass through. Wood, rocks, metal, your desk, your science book are all examples of opaque materials. It just absorbs it all. So we're saying, hey, you know, what happens with the absorption of light? With opaque, we absorb it all. With translucent, some. With transparent, almost none. All electromagnetic waves travel through empty space at the speed of light. What's the speed of light? It is 300,000 kilometers per second. So that is unbelievably fast, guys. So when we go back to yesterday, all these things are traveling through empty space, so from the sun to us, at 300,000 kilometers per second. And so, guys, if we do the math on it, and we are 150 million kilometers away from the sun, and you divide that by 300,000, that would tell you how many seconds it takes. So the sunlight I'm feeling right now or seeing right now literally left the sun like 6 minutes ago. That's how long it takes to travel through space because it's 93 million miles away. even though it's traveling at an unbelievable rate. So it says like this: microwaves are used for satellite signals. So I'm going to bounce my different things off a satellite, right? So I want to get the news around the world. And can they show me it happening? Well, guys, if you ever watch the news and you'll hear a person talk and say, okay, we have a correspondent over in Iraq. Johnny, what are you seeing? And then there's like a second delay, and then Johnny starts talking. That 1 second is how long it takes for the signal to bounce off a satellite all the way around the world. Now, is the world 300,000 kilometers? No. So it's literally less than a second to bounce those things off there. There's just a slight delay as they process it. But that's what's amazing. I can be talking to people around the world as my signals bounce off satellites because it's going so fast at 300,000 kilometers a second. That's empty space, guys. Our atmosphere is not empty space. Space is empty space, okay? Light travels through matter at speeds less than this, but light doesn't pass through all materials at the same speed. The particles that make up matter cause light to slow down. The speed that light passes through a material depends on the type of material. Unlike sound waves, light usually travels slowest through solids because of their high density, faster through a liquid, and fastest through a gas. So guys, that's opposite of a sound. Sound will travel faster through solids because the materials are highly packed together, they're highly dense, they can vibrate each other very, very quickly. Okay, so opposites there. As you think about our theme of this chapter of compare and contrast, your book is doing a good job of unlike, in other words, we're contrasting the difference between sound and light waves. You've cruised all the way through number 12 in your notes. Okay, these were all examples of absorption and how much we absorb between transparent, translucent, and opaque. Light changes speed when it moves through one material to another. If a beam of light strikes the border of two materials at an angle, the change in the speed of light changes its direction. This is called refraction. Refraction is the change in direction of light when it moves from one material to another. So they have this passing through and how it kind of bends it. When I think of the word refract, I think the word bend. When I think the word reflect, I think the word bounce. When I think the word absorb, I want the word take in. Wherever that was up here where we said it absorbs it, it takes it in. So refract bends light, guys. They'll tell you that right here. Refraction is the change of direction when light moves from one material to another. You can see refraction by placing a spoon in a glass of water and looking at it from the side. The spoon seems to be bent. This happens because light changes direction when it moves from the water to the air. Now guys, they don't have the spoon in your book, but they have this one. I am underwater and I'm taking a picture and these trees look a little bit crazy. I mean, this whole picture looks crazy. Why? Well, you would think that the ground wouldn't curve up here. You would think it'd be kind of a straight line, but what's happening? We are bending light as we are moving from water to air. That's exactly what's happening when I look through a glass of water at a metal spoon through the side, okay? So refract bends it like this. Cool, right? Absorb just goes in, and let's finish with reflect. Light that isn't absorbed and doesn't pass through a material is reflected. Reflection is the bouncing of light rays off of the surface of a material. If the surface is smooth, you may be able to see your reflection in the material. When light strikes a mirror, for example, the light reflects back so that you can see yourself. Think about places where you can see your reflection. Why can't you see your reflection when you look at a wall? Or maybe your science book is a little bit better because our walls definitely have little bumps all over it. But my science book looks pretty smooth is what they're saying. These surfaces may seem smooth. Using a magnifying glass, however, you can see many bumps and holes. Light that strikes these surfaces bounce off in all kinds of different directions because it goes into those little holes or bumps and it bounces it not straight back at me. So a surface must be smooth enough for light to bounce back to your eyes in order to see a reflection. So in other words, a mirror needs to be super smooth. Sometimes I can see my reflection in water. So I'm looking at a lake. I might be able to stare over a dock into the water and see my reflection. Can I do that on a really windy day? No. The waves do not allow it to bounce back to my eyes. It reflects it all over the place, right? Okay, so that's what they're trying to teach you. Okay, last but not least, let's see how we see colors. The wavelength of light that an object absorbs and reflects determines its color. Here's why we absorb heat. Black objects absorb almost all the light that strikes them. When you look at a black object, little light is actually reflected back to your eyes. So it's absorbing it all. Thus, when the sun is hitting my black shirt, it's absorbing it all. I'm absorbing all the sun's heat. What's happening with white? White objects reflect almost all of that light that strikes them. So what is white? White is a combination of all the wavelengths of light. So if I'm seeing white, it's because all these things, guys, is bouncing back to me. Your book tries to show you this. It starts out like white, and then it divides it into its spectrum here. And then if it bounces back and all of them are coming back, it's back to I see white. What happens if it goes out and nothing comes back? I see black. How do I see colors? An object appears red if it absorbs everything except red. So when you look at an object, you are only seeing this little wavelength of red bounce back to your eye. All the rest of these colors of wavelength got absorbed. Grass is green because green bounces back. So in this case, everything here, the purple, the yellow, the red gets absorbed, the green bounces black. Blue reflects only blue. Everything else is absorbed. So let's do 21. So the color I see is the color that gets reflected, 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 right? What gets reflected back is what I see. Some of us might think, I see green because it absorbs the green. Nope, then the other colors would be reflected back to your eye. So what you see is what gets reflected back to your eye. Okay, guys, what are three things light can do? Absorb, reflect, refract. What are the three types of surfaces? Translucent, transparent, and opaque. So keep both those lists of three in your mind as we go through that. All right, next week we'll get back. We'll start with a big old test on this lesson or on this chapter of heat and energy. Blessings on your weekend. We should maybe do some extra credit. Who gave us the spectrum here? Isaac Newton gave us that. So write down Newton equals spectrum. This is called a spectrum. We send it through this different glass shape. It's called a light spectrum, and it divides it into its colors of the rainbow. Roy G. Biv. All right, have a day.